So this one, we're going to combine two sinusoids again. We have two electrical sources that have models in this form. Difference is the phase shift is 30 degrees, which we'll do it in radians. This is pi over 6. And the outputs are 20 and 35. So that means V1 equals 20 cosine x plus the minus pi over 6.
I don't know what's minus one.
Doesn't really matter.
Because it doesn't,
Because it doesn't tell us which way it's offset. It doesn't also,
since they're repeating it, like.
it's repeating. Yeah. Your maximums, since they have the same period. So one of them needs a minus or a plus pi over 6.
And then it also doesn't matter which one.
Which one? Yeah, because the starting point is kind of arbitrary. They're repeating, they're going to hit the same repeats and same combination every, well, 2 pi, because the period of B is 1. So we're going to take and put these into Euler form. So it's cosine, so it's the real. 2e x minus pi over 6 I plus 35 e to the xi.
Then we distribute.
Distribute, and I'm going to distribute and split it like so I kind of did those two in one step. Now I'll factor out the e to the xi. Oops, this is 20. That's the real part. Now I'm going to go to my calculator and add those. No, why did I make it 30, not 35? Twenty negative 6 I plus 35. And I'll convert it back to polar. Complex number tuples. It's a little hard to see in this format, but I'll put it back in a second once I get it copied down.
We factored out e to the xi, and there's just converted the middle back to Euler.
Yeah, so I added them with the calculator and converted back to Euler form. Which the calculator says convert to polar, but Euler and polar are a direct conversion.
Oh yeah, I guess now the numbers changed, just a different way to.
Mm-hmm. So then really don't actually need these parentheses here. I just need it to be a time. So I multiplied the two e's, which means add the exponents. factor out the I. Cosine. So my maximum voltage is 53.3. That kind of makes sense. So I guess they did it in degrees. I would not do it in degrees, but and they did plus. It doesn't matter, you end up with the same thing. Um, I'm pretty sure 19.2 is 0.189.
If they wanted like a, the angle, they would have to be specific with, like if you were adding or subtracting.
Yeah.
Which you're.
Oh, we have a very different angle. That's interesting. 10.8 is very different than 19.2.
Theirs is in degrees and ours is in radians. I think.
Yeah. Um, well, I could just convert it. I suppose that might matter which one I put the pi over 6 on.
Did they put it on this different one than us?
Yes, they did.
The same,
We got the same voltage.
that's all we need to find it.
Yeah, I'm gonna see if this would work out. I was like, it gets you the same voltage. It might not get you the same angle depending on the offset. Oh, yeah. So depending on which one you put, you'll get the same maximum voltage. Your angle will be different depending on which way when you put it in where. This one, I'm pretty sure based on the last size is going to be 19.2. I shifted it the other way. Doesn't matter. And if you look at their answer, they actually do say this is a possibility. This is a possible pair. So you get the same maximum voltage either way. That makes sense? There's your combining sinusoids.